what we're seeing is there's just hasn't been quite as much pickup of it as we would have expected. So a lot of interest, a lot of value, perceived value, but it's moving a little bit slowly. I think what we're seeing, even for single use cases, we've got clients that are, seeing hundreds of thousands of dollars that can be saved even with single use cases. So, the takeaway there is there's a lot of kind of stored value here in doing something with predictive maintenance. So definitely worth taking a look at and seeing if there's value you can add to your company.
On this episode of CloudUp, we're going to be getting beyond predictive maintenance as a buzzword and focus on the what, why, and how you can make progress quickly. So welcome to CloudUp, the series where we explore the coolest things built on the cloud today, brought to you by Gusto. Today's topic, we're going to use machine learning to predict maintenance events, and there's a ton to dig into here, so let's jump into it. First off, let's talk about how companies perform maintenance today. Is it proactive? Is it reactive? And kind of what's the impact of that?
Yeah. So, we definitely see companies doing both, reactive and even proactive maintenance. I think the more advanced companies we're seeing are doing proactive maintenance in the sense that they're really doing kind of maintenance on a schedule, right? So preventative maintenance. So over time you can develop some experience with when you should replace things. But what we see there is that's not sort of optimized, right? So that's not, in some cases you're gonna replace things too early. In some cases you're gonna wait till it fails, right? And so it's difficult to kind of get it just right. So there's some cost to that, right? Like you do it too early, you're losing some material usage that you could have gotten, and at volume and scale, like that can be a lot of money. And if you wait till it fails, obviously you might have, if we're talking tires in a fleet, right? Trucks out of service, maybe has an accident, liability issues, right? So there's cost to waiting too long. And so what we can get to with predictive maintenance using machine learning is we get that a lot tighter, right? So not saying we're gonna ever get like 100%, right? But you're gonna get a lot tighter inside that window. And so we'll be able to save on material, but also prevent, more of those failures from happening, right? So that's, to me, the big impact.
Yeah. So going back to your point about just reacting and not being able to predict the impact of failure, not good, right? It sounds kind of like I rolled in high school with my Malibu. But let's talk a bit about how using predictive maintenance can help avoid some of those unexpected costs.
Yeah, so again, it's really being able to optimize that time window, and we're doing that by having a lot more data, right? So we've got kind of a wider range of data that we can take advantage of, right? So we can use somewhat static data like make and model, so a tire or piece of equipment, which tells us something about how it's constructed, and there's some predictive value to that, to how long it's been running, what conditions it's operating under, to like real-time, we call it telemetry data, like temperature and tire pressure, vibrations, that kind of thing.
Okay.
All those things together then really can be used to build a good model.
So these are key attributes, right? That ultimately, humans can even understand the basics of those key attributes. But I imagine that at scale, when you have millions and millions of events, it's really hard to understand what's happening, how to use that data and create, classified information that fits into categories that we understand.
Yep.
And so, I imagine by using, machine science and cloud ML, we can use some of that information to train models. So how does that all work?
Yeah, so that's a good question. So what we find still in machine learning, there's a lot of value still to human input, and the primary value of that is in this area we call sort of feature engineering. It's just a fancy word for sort of knowing what data elements will be predictive of failure, right? So it's still helpful to have domain knowledge to sort of pick those data attributes that should be included. But then what we can do is we can take advantage of the machine learning technology to take that data and then create the algorithm for it based on machine intelligence. So it's not something a human has to spend all this time engineering the algorithm. Their focus is on getting high quality data in place that we can use to be predictive. And with the cloud really brings to us the platform to run all that on. So a lot of times a data scientist that's working in this space won't have infrastructure background or development background. So what Cloud Platform can give us is a lot of that just as a service, so we don't need to spend a lot of time or having broader skill sets in that team to build out these models.
Sweet. So now we're going to take a quick break to hear from our sponsor, and then we'll come back and do some jamming on the Jamboard.
More and more, we're seeing organizations want to be really strategic with their success, and part of that means they're moving to the cloud. At Augusto, we're seeing a big uptick in clients using Google Cloud Platform for their online business operations. So whether you're thinking you need a boost with AI, machine learning, or you just want to build something new and fast, Augusto is an award-winning partner who would be happy to help you with your needs. We've been Google's Cloud Partner of the Year multiple times. We've got a few other awards as well. And we would love for you to get to know more about us. Okay, I can't take anymore. By visiting Augusto.com, you can get a free guide to your company's strategic plan for heading to the cloud. We'd love to see you there. Now back to the show.
Welcome back to CloudUp. In today's deep dive section, we're going to focus on how you can get started on predictive maintenance, and Mark's going to take us through kind of our approach.
Yeah, so definitely where you usually want to start is pretty basic, right? Just framing your business problem. But essentially that's just thinking about use cases that make sense for your business, right? So pretty simple approach. We essentially start out with, IDing the business area we're focusing on. So example of that is going to be, so let's take the tire example we've talked about a little bit. We're spending too much money on, recovering from failures of tires in our fleet, right? So just kind of framing up like that's an area we want to focus on. And then what we want to do is dig in a little bit deeper to that and create, an actual business question that we're trying to answer. So in this case, that'll be something like, can we use, predictive maintenance with machine learning to better predict failure than we're doing right now with our preventive maintenance program? So just what is like a more specific thing that we're trying to target?
And this is really an impact, right? So
Yeah.
we're trying to frame this up as, right, high value, low risk, but a problem that's going to impact this organization in a material way that's considered financially viable.
Yep, but it's a high level problem. It's a framing of the problem in a way that we can target. Is it something we can do, right? So you have to think about here. Typically, you're thinking about like, what does failure mean? Tire case is pretty easy. Tire blows up, but with a machine, does it just slow down? Does it actually shut down the line? So you have to frame like, what is failure for us? What is the thing we're trying to detect? And some sense of what's different than what we're doing today, right?
Okay.
And so then that leads you to kind of selecting a business metric. So here we're trying to get to, say we're trying to target, tire failure, right? So, business really, it's our success metric that we're trying to get to. So say we're trying to get to, for us right now, we're predicting at about 70%. Can we get to 90, right? So we have a target, right? So you really, in this first phase, you're just trying to narrow down the focus of what it is that you're trying to do.
And percentages obviously matter when you frame it up like this, but in some cases, if the impact, even if it's 75 or 80%, right? So let's say it's 5% or 10% better.
Yep.
In some use cases, that can be really impactful.
Yeah, you can turn that into so we're moving from say, 80, we're going from 80 to 90, and you'll be able to turn that into dollars. So that might be,
right.
For you, 50 grand, maybe it's like hundreds of thousands of dollars, depending on kind of what that looks like for you.
And so the way to think about this is I've got humans today that maybe can react to a problem, but when I'm using a system that can handle just massive amounts of information and then predict an outcome, and I can alert on that prediction, right? So you can also think about sort of downstream as I'm framing the business problem, what's the ultimate impact if I can go from this sort of narrow use case to something that has scale?
Absolutely, and so you should think about this as a place to start. And a lot of times what we'll do is we'll look at a whole bunch of use cases. So you might start out with maybe 10 or 12 ideas, right? And so we'll kind of run this process through with those 10 or 12 ideas, and out of that we'll get to hey, if we can hit these success metrics, these things, sort of logically bubble to the top, right? So we're looking for, hey, we found some high value potential here. And then what we would move into is like, how do we start to test that out and see if we can actually do it?
Cool.
Yeah.
All right.
So that leads then to, so that's kind of just framing where we start, right? So, and then where we're going to here is really we're trying to get to somewhat of an iterative process of learning, right? So try to frame this up as, it's really just kind of think about this as a circular pattern here where we're kind of doing a continuous process, and where we're starting is where all of the ML really needs to be is in data prep. So data prep is really, talked about this a little bit already, but it's essentially pulling in data from a bunch of different places and doing some data exploration, making sure we can suss out what are predictive variables. So again, with the tire example, we're talking about things like, make and model of tires, talking about how long the tires have been running, we're talking about temperature, tire pressure, all these kinds of things. We're pulling that together. And then this is the place where domain knowledge is important. You build this stuff up, you explore it, you do some visualizations, maybe doing some graphing, like you have some thoughts on what's predictive, but in this phase, you're really spending time determining whether it really looks like it's going to be predictive. And in this case, you're sometimes maybe you're creating a set of absolute values, you're looking at median values or moving averages of data, of variables. So this is a part where you're spending probably the most of your data engineering and science time really is pulling that data together and shaping it in a way that you can use it.
Are we trying to, in this phase, do we try to understand what a representative amount of data or a relationship means to humans yet? Or are we just trying to make sure that the data is in a form that's sort of repeatable and consistent?
Yeah, I mean, it's a little bit of thinking about what you can actually operationalize. And then from a model building perspective, it's about throwing out things that aren't useful, shaping things in a way that look predictive. So yeah, it's really kind of all of that. So kind of you hear terms around data engineering, data normalization, that's kind of what's happening in this phase. We mentioned a little bit earlier, sort of your feature engineering. You're really like pulling together the things that look like they're going to be valuable.
Okay. And throwing those things out that maybe won't be.
Exactly.
Right? Yeah. So it's not just getting everything. It's also trying to be smart about what you are using, because we're trying to, again, move relatively quickly to get to some validation of the business problem.
That's right. In some cases, you'll already have this, like in a data warehouse. In some cases, there's going to be some work to get the data. But this is sort of the foundation, really. We have to have good data and lots of it.
Cool.
So then from there, we'll move into what we call model development. So here, this is really where the machine learning part kicks in. And sometimes there's straightforward answers to what type of ML approach we'll use here. But you may experiment with a few different options and kind of see how that susses out. So there's a little bit of data science to this part, but here's a lot of where we're letting the machine now use all this data that we got and building models from it. And so we're doing this typically with a subset of our data as we're kind of engineering models that look like they'll be valuable.
Okay.
So that's usually, this is the machine part, and then we'll move from there into an evaluation and review. And so in this phase, what we're doing is, so again, we've taken sort of a subset of our data to build a model. Now we'll run that model against like a test holdout set of that data. So we'll have trained a model, and here we're running that against some test data to see is it actually predictive? Because sometimes you may overfit, the model may get overfit to the data you used. If you have other data that doesn't look exactly like that data, maybe it isn't quite as good as you thought. So this, you want to do some work here to make sure that it is as predictive as it looks like it was when you're building that model.
Okay. So you're actually looking at how well this information or this model is predicting, right, the outcome that your hypothesis is expecting.
That's right. So there's, is it performing as you thought? And at this point, we're all operating here very much in the cloud, right? So cloud platform tooling, usually a couple of data engineers, data science people can kind of do all this work.
Okay.
And here already, you might have some iteration. So if this is bad, you may go back here and like, all right, we need to take a new approach, right? That can happen.
Sure.
But ideally, we're moving on to, looks like we've got something that's useful. Now we'll get into deploying that model. And this can be straightforward if you've got a lot of the things in place, but this could involve like, okay, now we're putting sensors in the field. Maybe we have some edge processing that we need to do. So we might engineer like a mini data center close to the edge where the data is.
So you're gathering more data.
Potentially gathering more data, but definitely creating the infrastructure to wherever the feedback loops that we want are available, right? So we put a model out there, and now what do we want to have happen? So if we're predicting tire failure, we want to alert somebody that, hey, the tire's about to fail, so somebody does something. So here is the work we do to get the model out there, get whatever tech deployed to do alerting. If we're alerting a driver directly, maybe it's notification immediately in the vehicle. Or maybe it's to a dispatcher that lets them know, it depends kind of how we want to architect it. But this is when we're really kind of operationalizing the whole thing. And in the first rev of this, this may be a small group, right? You're going to want to not like affect your whole fleet, because when you go to the field, you inevitably figure out things that you didn't think were going to happen. So in this point, you're kind of, again, validating all this stuff works in the real world.
Okay.
And making tweaks, that will fit for your business.
So when we go back to, this first process, which is framing out the business problem, right? Understanding these key components, right? Defining some sort of targets of success that are important for the stakeholders in your organization. And then we start, right, iterating on this sort of loop of processing. How long does this usually take us?
Yeah, we can typically do like a small run of this in short time period. You might be able to do something as fast as 4 to 6 weeks, depending on a lot of it will depend on where you're at with your data. Sometimes there's work that needs to be done to get that data in place, so that could take a little longer. So that data engineering piece, that will drive a lot of kind of how quickly the rest of it will go.
In our experience, we typically run workshops and helped the executives and the engineers that we're working with at organizations, our organization partners, really help understand what's possible.
Yep.
So that they're not stepping into mistakes that typically, because of inexperience and not understanding this process real well, that they won't do that, right? That they'll make good choices, and we'll help them so that they're focusing on the right problem, right, with the highest value, and ultimately is going to have the highest impact to their organization.
Yep, that's it.
All right. Thanks for watching this episode of CloudUp, where we focus on the coolest technology delivered on the cloud. Would love to hear your feedback, comments on how you can use predictive maintenance in your own industry, how you're making progress in this space, and if you have questions or challenges that we can address here around predictive maintenance. Leave a few comments, leave a few notes, ask some questions, and we'll give you some swag. Thanks again.
CloudUp is brought to you by Augusto, a leading Google Cloud platform partner. Like this episode and subscribe to our channel on YouTube to learn more. We would love to help you out. Visit Augusto.com to learn more.